Hey, what's up guys? This episode we're gonna start by creating some gravity. So we're gonna implement the gravity, and we're also going to create a falling state, so our player finally is able to drop down some kind of floor like this. And then after that we're gonna make sure he comes back on his feet and back into the walking state. So without further ado, let's get started. Alright, first step is to go back into the base motor, and in there we'll declare a new function here. So my function is going to be called, it is going to be a public void change state. Now you already guessed it, this is used to change the state. By the way, it's going to take a state name as a parameter, but what this is going to do is whenever we need to change a state, this is going to handle everything. So starting by getting the type that we're sending, because right now what we're sending is a string, and we can't really change our state with a string. That's just not going to work. So to do that, we are going to declare a type. So system.type t is going to equal system.type get type, and in there we can pass a string. So we're going to say state name. Now that we do have our state type, what we're going to do is take the actual state, so state, and destruct it like this. Then after that we're going to say state is going to, well, state is going to equal GameObject.addComponent, and we're going to send him t. Don't forget to cast this as a base state while you're at it. And then finally this new state, we need to construct it just like this. Okay, so this is simply going to be it for the change state. It's going to be quite simple. Now in this episode what we wanted to do is we wanted to have a falling state, so wanted to start implementing some gravity. In order to do so, we need to know if the player is on the ground or not, because we're not applying any kind of gravity to the player if he's already on the ground. So we're going to declare one big function inside the base motor that is going to check if the player is on the ground or not. And the reason we're doing it in the base motor is because we're not only going to be using this on the player, but for every single NPCs that is grounded or that is not flying. Alright, so down here I am going to say public virtual bool, so this is going to return a true or false, and I'm going to call this grounded. And in here I will also declare a raycast hit field and a vector3 ray. So this one, it is going to be where the information is stored, and this is going to be where the origin of the ray we're going to be casting is. So let's start by casting a middle raycast, and I'll explain you what this is in a second. So middle raycast, ray is going to equal new vector3, and we're going to take the controller we currently have, .bounds.center.x, and then controller .bounds.center.y, controller.bounds.center.z, and just after that I am going to draw it on the screen. So debug.drawArray, I'm going to draw the ray that we just assigned in the vector.down direction, and then after that I have to give a color, I think. So color.green. Oh, I forgot to return something down here, so we're just going to return true for now. Actually false. We're actually going to return false just for now. And I am going to go in the player motor, and down here I'm going to say grounded in the update, just so we can test this out. We're going to remove this line a little bit later on. So okay, doesn't seem to be any errors right now, so I'm just going to hit play. And let's go check this out. So this is my cube, and we should be able to see a raycast just beneath it in the scene view. And as you can see, it is right there. So we are casting a ray from the center of our cube. So this is the center of the cube, and it's going down. Alright, so we're just gonna test out some things, right? So if our cube is here, say right here, this is going to be considered as grounded because the raycast is hitting the floor, and that's just fine. That is alright. So but if we move over here just like that, it is no longer considered as grounded. This is considered as falling, and we don't really want this. We don't really want the cube to be considered as falling right now. Same thing if we actually take this and let me move that in Z, and we end up just like that. So right now, if we're just looking at the cube, we could say, oh yeah, he's on the floor, right? But the raycast by himself is saying that he's not on the floor because he's not touching anything, and that's a problem. So what we need to do is we need to put some additional raycasts on the four extremities of the cube, and that's what we're gonna do right now. So down here in the debug, actually we're gonna leave the debug, but down here I'm going to cast the raycast because we were just drawing it before. I'm going to cast it for real this time. So physics.raycast, and then we say we start from the ray, vector3 dot down again, and then we want the information to be stored in the hit field that we just created. So out it, and in there we have to give it a distance. For now, let's just put it at 3.0. We're going to change it a little bit later on. Close this off and open the curly braces. And if we hit the floor for real, we're going to say return true. Okay, so that's our first raycast, but we still have the same problem that we just discussed. So we need to cast 4 additional rays, and to do that, I'm going to go up here and declare some floats just to ease the code just a little bit, because it's going to look messy if we just copy paste this around. So I'm going to declare a float. I'm going to call it a Y ray, and this is going to be the Y value of every single ray because it is always going to be the same value. So this is going to be controller.bounds.center.y minus controller.bounds.extent.y. So with this right here, with this call, we are actually right in the middle of the cube, just beneath it. So let me just show you real quick. We're going to be exactly below the cube and in the middle. So we're going to be right here in the cube. And also we don't necessarily want to be right here, because say the cube is like this, so we're, you know, like the bottom of the cube is beneath the floor. If this happens, then we are considered falling because our cast is going to start here and we're not actually going to hit the floor. So what we're going to do is we're going to say bounds at center.y minus this plus 0.3f, and this is going to be just a security offset. Okay, now remove the semicolon. What we're going to do is we're going to put a comma here and keep declaring some float. I'm going to say center.x is equal to controller.bounds.center.x. Now center.z, actually, controller.bounds.center.z, and then I'm going to declare the extent, controller.bounds.extent.x, and finally extent z, controller.bounds.extent z. Now we can close this off. And we're actually going to come here and clean our first raycast. So our middle raycast is going to equal center x, y ray, and center z. Now what we need to do is copy paste this, put it just below, like this, and we're going to say center x plus extent x, y ray, center z plus extent z. Take this again, so copy, paste it 3 more times, just like this, and we're going to play with the value. So this is a middle raycast, it works just fine. This is one of the 4 raycasts, and now we need to change the signs around. So the first one is going to be center x minus extent x, and we leave it like that, and this one is going to be center x minus extent and center z minus extent z. The last one is going to be center x plus extent x and center z minus extent z. Alright, let's go in game, check this out. Okay, so as you can see right here, we are currently touching the floor, and the reason I can say that is that the first raycast, this one, is being tested over here and it is returning true. So we hit return, so we don't have to calculate anything beneath that. We simply hit return and this hands ear. Now if we take this off the stage, it's going to start checking for the other raycast. So let's try that. Alright, so we're on the very edge now. I'm gonna move this just a little bit off, and as you can see, one of these is being calculated and then the other one, and then finally the third or the fourth raycast is being calculated here, and it is hitting the floor, so we don't actually have to check for the last one. Now our cube is still considered as grounded, and say we move it off the stage, you can see the 5 raycasts being tested, and now he is officially falling. Well, not yet. I mean, now he is officially considered as not grounded. So, alright, now that we do have this, we need to create a falling state. And that's exactly what we're going to be doing right now. So go back in the game, we are going to hit create C# script, and this is going to be a falling state. Now again, when we create state, it's fairly simple, so the code that's going in there is really easy. We simply change this for base state, and now we have to implement a public override process motion. Okay, but what exactly are we supposed to do now? We don't have anything calculating the gravity, and that's exactly what we should be doing next. And in order to do so, what we're going to do is we're going to go back in the base state, because calculating gravity is going to be something we're going to be doing a lot with different states. So having it inside the base state, we can apply it to multiple stuff or multiple state a little bit later on. We don't have to code it every single time. So let's go down here in the base state, and we're going to start declaring some fields, actually some function. So we're going to start with a protected void, apply gravity, and we're going to take in reference the vector3 input and then float gravity. And we're also going to declare another one for the cleanup purpose. We're going to copy this and change the first function for apply speed. So we're going to take the same parameter, but instead of gravity we're going to say speed. So the reason I wanted to have a apply speed function is so we can clean up the walking state just a little bit, so it looks a little bit better and we know exactly what's going on in there. So let's go back into base state, code this. This is fairly simple. Since we are taking the vector3 in reference, we can simply say input times equal speed, and this hands here. That's fairly simple. And now as for the gravity, okay, so what we're gonna do with the gravity is we are going to keep track of our velocity in the y-axis every frame, and this is something our motor should have because we might be using it for more than just a single state. So let's go back in the base motor. We're gonna declare some fields up here. The first one is going to be a private float, and this is the terminal velocity that I'm gonna set to 30.0. And also, when we do create one of these, I also like to have a public field so we can access it public property. So I'm going to say public float terminal velocity, this one with a cap, and we simply say get return terminal velocity. Okay, and now to keep track of our actual velocity, I'm going to go right here and say public float vertical velocity, and we keep this with caps because this is also going to be one of the important fields, just like the move vector. This is going to be important property. We're going to be setting this every single frame if we are actually using it. So okay, now that we have these, we can go back in the base state and start coding our apply gravity function. First thing we are going to say is motor.vertical velocity is going to be minus equal to the gravity we're receiving in parameters times time.delta time. And then when this is completed, we are going to clamp our value. So clamp matf.clamp, and we're going to clamp the motor.vertical velocity, and we're going to clamp it by minus motor.terminal velocity. Copy this because this is also going to be the max value, So what this does is we're going to take the, well, actually we have to set this. So motor.vertical velocity is going to equal this. And I'm going just to put it on different levels so I can see, like this. So it's going to take the value we currently have and clamp it with the minimum, so it cannot go below this and it cannot go above this, which is perfect for this kind of function. And finally, we take the reference vector we get, so input, and we're going to say dot set. We keep the same value in x. We also keep the same value in z, but as for the y value, it is going to be motor.vertical velocity, and then input.z. Alright, so this is our apply gravity function, and I think we're pretty much ready to test this out, just have everything ready for testing. But if we go back in our logic, then the walking state, we start right here. Well, we start right here and we process this motion. There is no way to get out of the walking state, because if you remember, we have nothing in here. We have nothing in our transition function. And what we wanted to do is we wanted to make sure that we can transition from a state to another. So to do that, we're going to code this in the walking state, and we are going to override the transition function. Okay, so how are we exactly supposed to transition from the walking state to the falling state? Well, it's fairly simple. We're simply going to check, are we grounded or not? So if we are not grounded, so motor.grounded, don't forget the exclamation mark for the not grounded, then if that's the case, we are simply going to say motor.please change state for falling state. This is the exact name of our script, and then he should just change state. And while we're at it, right here we implemented the apply speed function. So remove what we currently have, and we're going to say apply speed reference input and motor.speed for parameter, and then we return the input vector. So it's a little bit cleaner and we can see what's going on now. Okay, so let's go in game. Check this out. Oh, we have an issue right here. So not all code paths return a value. Oh, we forgot to put something in our falling state. So let's just go ahead and do it real quick. It's super fast. Apply speed. We're going to start by applying a speed to this. So reference input motor.speed, and just below that we're going to apply gravity. So apply gravity reference input motor.gravity, and then return input. Alright, and while we're at it, we'll just copy paste this transition thing and put it in the falling state as well. And we're going to change, say, if we are grounded, so remove the exclamation mark, then we change state back to the walking state. And we should be able to switch from falling to walking now. Okay, so let's put our cube in the air just like this, hit play. And he's not falling. Let's go see why. So our movement is calculated in the update motor. So we take the input, that's fine, we process the motion, so that's also fine, but we never actually check if we're changing state or not. So right here we're going to create a new call. So this is going to be check if we need to change current state. And right below that we're going to say state.transition. And now this is being called every frame. Also remove the grounded while we're at it. We're done testing this. Hit play. And the cube is now falling, and it is considered as grounded right now. And well, the reason why it is considered as grounded is because this raycast right here, this is only the debug drawaway, so this is only 1 meter, but the actual raycast we said that it is 3 meter long, so it is casting from, let's say, here, then 3 meter below it. Say we were to take it just like this, you can see, well, first off, you can see that he's switching from the falling to walking state when he's touching the ground, but you can also tell that he is way above the level that he should be when considered grounded. So let's go back in the base motor. In here, we're going to change this 3.0 value for another value. So let's go over here. We're going to declare a float. So private float, and we're going to say ground ray distance. Ground ray distance is going to be equal to 0.5. And also, since we're there, we're going to declare something else. So another private float that we're going to declare called ground ray inner offset. We're going to set that to 0.1 for now, and let's just go down there. I'm going to tell you what this does in a second. So first, this, we know what it does, so we're simply going to change this here. Actually, we're going to change the 3.0 for our new value, so let's put that here, like this, in every single of those. And as for the ground ray inner offset, I wanted to put here in the extent field. So where it says extent X, I'm going to minus the ground ray inner offset. Same thing here. And this way, if we check in game, you can see that our ray casts right now are not being cast from the extremities of the cube. They are being cast from 0.1 towards the center. And I just wanted to put that there just for the sake of not looking too stupid when it's supposed to be grounded or not. So that's pretty much it. And now this is a proper distance from the floor for it to be considered as grounded, so everything seems to be working just fine. And we're actually going to test this out a little bit more by creating other planes. You don't have to do this, I just want to make sure everything is fine, so I'll do it on my side. And then I'll take this and make little steps, just like that. Alright, let's go in game, test this out. And I just realized that we have one potential error that we're going to fix in a moment. Put back in scene view, and we can tell that our cube is falling, but it's falling way too fast. We're never actually resetting the vertical velocity, so this thing over here just keeps going down every single frame, but it's never actually being reset. It should be reset when we hit the floor, right? So we forgot to say that whenever we do hit the floor, whenever we do come back inside the walking state, this should be back at 0. And a little bit later on, when we actually do a jump, then this should be back at well, whatever the jump force is. So in the walking state, what we're going to do here is we're going to we're going to say public override, and then we're going to override the construct. Now make sure you leave the base.construct in there, because we still need to assign the motor of the state. And once we do have that motor, so once this is ran, then we can say motor dot vertical velocity is equal to 0, simply resetting this. Alright, so last try. This should work now. Hit play. And as you can see, we have some smooth, really smooth falling. And that's exactly what we wanted to do this video. So this was a fairly long video, sorry about that, but we got a lot covered, and we can now start building a little bit more stuff from that. Maybe the camera next video, who knows. Guys, thanks for watching, and I will see you next episode.